So if you recall, we had left off last time with a discussion about the for each terminal operation. And before that, I kind of talked about what a terminal operation was in general. Terminal operations are aggregate operations that appear at the very end of a stream and are used to initiate all the processing of the lazy intermediate operations, and then will do something that either returns no value, as is the case of for each or for each ordered, or will return a single value that's not a stream. So the long and the short of it is terminal operations can only appear once at the end, and they don't yield streams. So let's go ahead and talk about the collect terminal operation. And the example we're going to look at here is in my EX12 folder, which you can get at my GitHub repository. As before, we're going to showcase the Hamlet program in order to illustrate how collect works. So collect is a terminal operation that typically returns a collection. You can also return other things besides collections, but most commonly you collect things into collections. And I suspect you already know what a collection is. Collection would be something like a list or a set or a map and so on and so forth. You can actually write your own user-defined collectors, and we'll do that later in the course, and you'll get a chance to play around with those kinds of things. But for now, we'll focus on the predefined collectors. There's a bunch of different variants that are shown in this particular program in my GitHub repository. So we'll show how to collect things into lists, how to collect things into sets, how to collect things into maps. There's a couple different ways to collect things into maps. And what we're going to do here is we're going to create and process a stream that consists of the character names from the William Shakespeare play Hamlet. And each of these will show off different ways of collecting the results of that stream processing into a different type of Java collection. So you can think of a collector as basically aggregating stuff. It's kind of the opposite of a splitterator. We'll talk more about splitterators later. Splitterators take a source of data like a collection, and it splits it up into a stream, either a sequential stream or a parallel stream. And then a collector is kind of the inverse of that. It takes the results of streams processing and various intermediate operations, and it merges or joins them back together again into some aggregate element or some single element that's returned. It could be something that summarizes all the elements in the stream according to some criteria, like the max and the min, for example. It might be the result of joining a bunch of things together to form a single result, like a string. It might accumulate elements into various types of collections, and so on and so forth. So there's a bunch of different options that you can control. So probably the most common form of collector that you get out of the box is something that's called the list collector. And in fact, there's a factory method called toList that appears in the collectors utility class. So the collectors utility class, as you may recall, is a utility class is just a class that has a bunch of static methods. You can't make an instance of it. It's got no non-static state, and you can't subclass from it. You can't extend it. So that's what a utility class is. And the collectors utility class has a bunch of factory methods that, among other things, make different kinds of predefined collectors, one of which is the list collector. And so when you call toList, what actually happens under the hood, as we'll see later in the course when we look at this in more detail, is it makes a new array list object, and then it collects the various elements in the stream into that array list, and it comes back as a list. Very classic way of doing things in Java. You program to interfaces, but the actual implementations, of course, are actual subclasses that implement those interfaces. One thing to note about an array list, which is what I show here in the diagram, is you can have duplicates. So you can have many items that are the same. For example, in the play Hamlet, the character Hamlet there are two different people who have the name Hamlet. So those are duplicates. There's also two different people who have the name Fortinbras, for that matter. I don't think there's any other duplicates, but those are the ones that people are familiar with. So you could end up having Hamlet appear more than once if you use a list collector. List and this collector, the collect in general, is much less error prone than the for each terminal operation with a side effect. If you recall, we had looked before about using for each with passing in a method reference that will add the elements to a local variable of type list, blah, 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 blah. Remember, you had to not forget to allocate that local variable. It was just very error prone, very tedious, very brittle. So by and large, using collect is way better than using for each for most common operations. So the initialization is implicit. You don't have to allocate the memory yourself. And it's also thread safe. It'll work for both parallel and sequential streams without any changes in the user code if you do things right. So definitely go with that instead of using for each with side effects that store into collections. Another type of collector that you get out of the box is the set collector. And this is implemented, or this is achieved or created by using the toSet factory method, which appears in the collector's utility class. And as you can see here, if you say toSet, that will collect the results into a set. And what's the main difference between a set and a map or a list? You can't have duplicates in sets. Lists can have duplicates, sets can't. Out of the box, the kind of set that you get here is a hash set. There are other kinds of sets as well. There are tree sets and so on, but the default you get is a hash set, just like the default list you get with toList is an array list, as opposed to, for example, a linked list. So the main difference is that the sets are going to be unordered, and they don't have any duplicates. So that's one of the properties of a set, particularly a hash set. There's yet other types of collections you can create, and depends how you look at it, whether a map is a collection or not. It doesn't implement the collection interface, but I think of it as part of the Java collections framework. And a map is, as you know, a data structure that associates keys with values. And so you can also use various factory methods defined in the collector's utility class to create maps. Here's one way to do this. There's a toMap factory method in the collector's utility class. And what you do is you give it something that will classify the stream to create the keys, and then you'll also be able to define other method references and so on that will create the values and in the map, and then also handle when there are duplicates. So what you see here is we're going to use the toMap factory method with the identity classifier. What that says basically is each element in the stream, use that as the key into the map. So in this particular case, that's going to be creating a map that maps strings, because that's the identity of the elements that are in the list of character names from Hamlet that are in the stream. And then the second parameter is an integer, and we're going to have the integer be the length of each of the character names. So Hamlet, for example, would be 6 as length. Laertes would be 7. Horatio would be 7, and so on and so forth. And then the third parameter to toMap is a method reference that will sum the lengths of any keys that have duplicate values. Because again, a map can't have duplicates. It has to have unique values in Java. Unlike C++, we have multi-maps that can have duplicates. In Java, maps don't have duplicates. So if you end up with 2 Hamlets or 2 Fortinbras names, those will be summed up, and that the length will just be, 12 in the case of Hamlet, because you'd have 6 plus 6. So that's one way to make a map. And the default is to do what's called a hash map. And a hash map, as you can see from this diagram, is basically going to have a hash table, which is an array, and the array will either point to a linked list of key value nodes that hash to the same location, or if a location starts to get pretty densely packed, the hash map in Java will automatically convert over to a balanced tree, which is very clever. And so in some cases, you can have a balanced tree. Why do they convert to a balanced tree if you have a lot of nodes hashing to the same location? Because that way you never have more than log n depth to be able to find or insert or remove any item in the map. Otherwise, you could end up with a single linked list that would be really, really long, and you'd end up basically with linear time for each operation, which is not desirable. There are other ways of creating maps. more powerful ways using various other kinds of collectors. For example, there's the grouping by collector. And as you can see here, what grouping by does is it takes 3 parameters and we use it to create different kinds of maps besides hash maps. So here's an example, as we'll see, that uses a tree map. And we'll talk about that in just a second. So the 3 parameters that are passed to grouping by, the grouping by collector factory method, is identity, which is basically used to classify or partition the stream up into the keys. The mental model I have with the classifier is kind of like the drawer that you might, the partitioner or the utensil organizer that you might put into a drawer in your kitchen that will allow you to separate your forks from your knives, from your spoons, from your short forks, from your small spoons, your big spoons, and so on and so forth. And the basic idea here is that you classify things, and that's what ends up determining what the various keys are in the map. So in this case, again, it would be string. So we use the identity function, which will just say, take whatever the value is and use that as the key. The second parameter that's given to grouping by is a constructor reference to make the desired type of map. So in this case, we're going to make a tree map as opposed to, say, a hash map. And the main difference between a tree map and a hash map is that a hash map isn't sorted, whereas a tree map will be sorted. It'll be ordered by definition. So it's basically implementing the map as a balanced binary tree, as you see here in the diagram. And then the third parameter we're passing to grouping by is something called a downstream collector. And all that really means is it's a secondary collector that's used after the first collector, or first classifier is used to figure out what the keys are. The downstream collector then does something with the values to convert them into whatever you want the values to be. So as you can see here, what we're doing is anytime we have duplicate keys, we're going to sum the lengths up of the values, which in this case is defined to be the length of the key, and we're going to sum it up and we're going to have a running sum. So in a sense, that's basically the same thing as we're doing here with integer : sum. We're just using a summing downstream collector. And notice also this particular implementation uses a map of string to long, whereas up here we used map of string to integer. Okay, so that's a very powerful mechanism. There are other things we'll talk about later, other ways of using grouping by and other kinds of constructors to make other kinds of maps. For example, there's something called a linked hash map that we'll discuss later as well. Be aware that there are other ways of being able to create streams in the first place. So here's how we're going to use the pattern feature in Java, which is part of the regular expression package, in order to be able to take a string that has all the characters in Hamlet separated by commas, and then it'll split that up into a stream by giving a regular expression, which in this case is just the comma, and it'll use that as a way to partition the string up into a string. And then we would use the same grouping by mechanism we just talked about to turn that into the final result. So that's the end of our discussion about the collect terminal operation. You'll get a chance to use collect quite a bit. And in fact, you'll be using it together with your unsynchronized array. And that's why it's so important to have your unsynchronized array working properly, because we're going to be using that as the thing to collect into with the various programs we're going to do. So you'll get a chance to play around with a bunch of different interesting things, building upon your unsynchronized array to be the data structure that we're collecting the results of our streams into, both sequential streams and then later parallel streams.